Hi everyone, my name is Erin Fox. I'm on Twitter as Erin Fuchs. It looks like a spelling mistake, it's not. And I am a junior engineer at Major League Soccer, and it's my first job I've ever gotten. We did it in React Native, so I was hired to build a brand new React Native app from the start. So obviously the first thing that I Googled is, what is soccer? Don't know much about soccer, I've been there over a year and a half now. I know that a game is called a match. I know a couple more things about soccer, but I like this GIF because that's exactly how I felt starting out. Learning React Native, learning about soccer, learning about software engineering vocabulary. So it's just, everything is very, very confusing, and I could go on and on about being a junior in this industry, but for the sake of the lightning talk for 10 minutes, I picked some lessons that we're gonna go over. So the first one is jumping in head first. It's terrifying. Not knowing about React Native, I had about a week of React experience before getting this job, so a lot of questions going on. The second one is walk before running. So there's many technologies that we used as a booster seat for us to be able to start small and kind of grow bigger and faster. Writing checks your API can cache. Sorry, I see all you guys following me on my phone and it's distracting. Okay, so writing checks your API can cache. Somebody wrote an API somewhere. I don't, where's this data? What's this JSON object? The fourth one is best way to learn is to teach, hence why I'm here. I'll go into great detail for that. And the last one we have is stop, drop, and learn. So this is our app. This is what they showed us, I think, on my first day. We got our Zeppelin designs. I was like, oh my gosh, what's the shield doing there? Who is that shield? How do you go all the way to Jersey and the score is 2-2? And that's the end of the game. So just a lot of questions of like, where's the data coming from? Is this a video? Like, are we having like a native video player? So just so many questions coming up basically on the layout, the UI, like who's the designers, who's my boss? So many things going on. So it's pretty like self-explanatory that we needed to start small. And Samantha mentioned earlier about Storybook. And Storybook is such a great way for first-timers and juniors to be able to break down components and just build a tiny thing. I think my first component was a button, and I was so stoked. I was like, yes, a button, like, great, his button's gonna be everywhere. So it's just really a great way to work outside of a repository. So it's like I didn't have to search through a million files to be able to find where my component should be. So I was outside of the app, isolation. It gave me a ton of confidence to just pump out these components that we were doing. So my button. We started doing React Native on the web with Storybook. You can see we have our primitives, our heading, modals, a whole bunch of different things that we have within our web one. And then lately, this is a hot mess, but we started switching over Storybook to our own React Native component library app. So yeah, the UI and everything's kind of ugly, but it's great now that I've been able to do it on the web, and now I'm switching over to be able to build this component library kit on an actual app. So hopefully next year I could just come up to you guys and be like, hey, check out this app, like look at that button now. Storybook is just a great way to build confidence, build things in isolation, and really like pump out components when you're starting to build your app. So GraphQL, Chris did a great talk on it earlier, really, really liked it. GraphQL is so easy. It's easy to just be like, like what data do I need? Let me start typing it and like poof, like, oh, like here's what I need. So an example of this is our basic match query, date, home, away, goals. You get what you want, you get exactly what you need. Like a couple weeks ago, I was working on sports terms, learning those. Clinching, so when you clinch the playoffs, is not the same as clenching. So the entire time in meetings, I was saying, yeah, I'm working on the clenching. And I was like, what are you talking about? But when you make the playoffs, you're clinching. So I was able to do a GraphQL query and test to see if New York Red Bulls were clinching. So to see if that information was available is great, and the documentation is written for you. So again, using Graphical, we're able to be in isolation, figure out the exact query and data that we need, to able to just copy that query and paste it into the repository. So obviously, I didn't do all this on my own. We are big fans of pair programming at Major League Soccer. Being able to have someone next to you and help you out when you're the first time writing a component, or It's your millionth time writing a component. Everybody has their own styles, so pair programming is huge. And whether it's junior, senior, pair programming really helps you explain things. And I can't tell you how many times I've been pairing with someone senior and they have no idea how to do it. And I'm like, oh, you're a senior though, like you should know this. And so it's kind of like, yeah, we're at the same level. So it kind of like really helps with communications in that aspects. But sometimes you just have like a million questions of like, so working on notifications, like we use so many third parties, like how is this notification coming through and who's sending it? Just gets a little out of hand. So we have these things called teachable moments. So this is the stop, drop, and learn aspect of it. So we would just leave our laptops, go into a conference room, and really like whiteboard it out. And it was a safe space and an environment to ask any questions that we had. Sometimes it's a little scary if you're in an open office space and there's like a VP of engineering next to you, and you're like, I don't want to ask about state and props because I kind of understand it, but like I don't want to say it out loud. So to be able to go into a conference room and just ask your basic questions is really valuable time for seniors, juniors, really managers, anyone that's working on the project. So this is an example of one of our teachable moments. I always thought React Native was like one code base, one app, you know, you just push it and it works everywhere. It doesn't. So we kind of like came up with this metaphor of the JavaScript is the wood of the puppet, and the bridges are the strings, and then we have these two little puppets that are our iOS and Android apps. So this is probably took like a half hour for us to just like figure it out, and for me to fully grasp it and understand it, like I needed to visually understand and compare it to something else. So this teachable moment was very great. Another one was I just couldn't wrap my head around what GraphQL is and where our information was coming from. So we were actually just at the lunch table. You can see there's mason jars, and then our ketchup packets started becoming like our APIs, and then the forks and knives and spoons was our happy server, and then we got GraphQL and Apollo server and Apollo client. So teachable moments can really be anywhere. This one probably was 10 minutes at I don't know, I think we're at like Chick-fil-A or I don't know, something like that, where we were able to like switch everything around, and it just helped me really visually have it. So teachable moments really help you just like break it down, because some things that are obvious to some people aren't really that obvious to other people. So lightning talk, this is fast. Wrap it up. So there's so many technologies out there that help first timers, juniors, really anyone that's starting out with React Native, because it is so new. It's great to be able to have that booster seat of those technologies like Storybook and GraphQL that really help you prepare you for when you actually go into the code base and are actually pulling all your components together and having it just well-rounded. So you might be very confused, whether it's about soccer or being a software engineer or React Native, but then eventually you're like, cool, I'm making some components, I'm getting some data back, like this is awesome, I kind of like React Native. And then you celebrate because maybe you're not a junior anymore and you actually understand it. So thank you.
All right, should I get started? Okay, cool. Well, it's nice to be here at GraphQL Boston. Since like every other talk is about GraphQL, but I'm just gonna tell you a little bit about this project, an idea I want to share with you because I think it's really cool. And in particular, it's about the double. My name is Shawn, by the way, and I'm on Swyx on Twitter. And if you don't know of the double declaration problem, don't worry about it because well, I came up with it. So yeah. Anyway, so I work at LFI as a developer experience engineer. We're holding an awesome conference in San Francisco at the end of October. Really check it out if you're in the area and in the mood for some jam. I also help to moderate the React Reddit subreddit, where we have over 70,000 React developers. If you're posting a job, that's probably a good place to go because it's free to post a job, so why not? On to the double declaration problem. I invented it, and mostly just to name it, because everyone has it, they just don't know that they have it. And really, it's a situation where in GraphQL you have a string, and then you have your JSX component. And every single time you want to request something, you have to write your data requirements in the string, in the GraphQL string, and then use it in your JavaScript. And that seems like a duplication. And errors actually arise if you forgot to declare it in the string and you try to use stuff that you didn't request for in the JavaScript. There's also extra requests. For example, if you just have like random stray things in your GraphQL that you don't use, so you're requesting extra pieces of data. So it's just not very clean, and it's not very it doesn't feel like we've quite reached that goal of having a really smooth developer experience. So in order to solve this problem, I turned to metaprogramming. And my first reaction was to try to do a new GraphQL client using proxies. So kind of like how Mark was talking about Immer, just kind of passing in an object that kind of looks like the data object that comes in from your GraphQL client, but really it doesn't, because when you pull that data object, this meta, and you try to access a field, it realizes that it doesn't have that data object. For example, dog in this example over here, it actually goes and suspends the rendering and goes up to the cache and pulls that data down, and then tries to render again, and it realizes it doesn't have the next piece of info. Suspends, go up, pulls the render down, and all that. Obviously, it's super inefficient, but it was a really interesting science project. But that was my first attempt at exploring this problem, which I call React Blade. And then I was thinking about it, and I was realizing that this is inefficient because I'm doing so much suspending at runtime. So why not move it ahead of time? And that's what I call AOT, metaprogramming. And instead of inventing my own GraphQL client, which I'm totally not qualified to do, why not make it work with every GraphQL client? So that's the goal of the rest of this talk, which is to explain what I did with Babel Blade. So this is Babel Blade. You can play with it in the Babel REPL or AST Explorer, but we're just going to mess with the Babel REPL for now. And this is on babeljs.io if you've never played around with it. It's pretty cool. So this is a typical GraphQL app. For example, you got your GraphQL string up here, and you're using your data in the JavaScript down below. Can everyone see this? Is it big enough? Okay, I can. All right. On the left is the raw source code. On the right is the result of the compilation after the Babel transform, right? So I'm going to invent a new syntax. Let's just call it movie query. And I'm going to create a query. This is a pseudo function that I just made up inside of Babel. And I'm going to replace my query string. So it's gonna just fill in that query for me. But I need to tell my Babel function what my data requirements are. So I tag that data object with the rest of. Oh God, please work. Let's see. Oh, there we go. Okay. So I tag my data object together with the rest of. Well, why is it not working? Oh, see, it would be nice to have. Yeah, well, that's the fun of live coding, right? So in Babel, this function, this create query function, exists only in Babel and is compiled away at build time. But what it lets me do is create this meta object, and when I tag it, it follows through from data to result.movie, and movie gets renamed as actors, and then actors.supporting, actors.leading. It generates the entire GraphQL string just from the usage of the data, and so it always is paired. So for example, if I want to fix the little bug that I left in here, and I want the actors from the movie in supporting and leading roles, I can just destructure from that role, and it fixes that GraphQL string. So basically, it just it pairs your usage of data along with how you use it instead of having to separately request it, and it makes your iteration speed much faster. So our goal now is just to go through the entire GraphQL spec and just show you how to use this. So we've already done fields and operation names. So here I've named the operation as well as I've done the fields in GraphQL. But there's all these other features in GraphQL, and we're going to go slowly through them. So arguments and aliases are kind of paired concepts. So let's say I want to have a movie ID. I just fill that in over here with, let's say, ID equals 5, and that is supplied as alongside to the query, as well as given an automatic alias, as well as given that alias inside the code. And that is exactly how GraphQL works, but now you just don't have to take care of it separately. And that's so right. And the variables, it seems are kind of like they actually kind of no longer necessary, but I just did it anyway just because. So let's just have a movie ID, which is like an ID, for example, and then we'll take the ID over here. Something of that sort, right? Like that's how you sort of set up GraphQL query variables. But really, you kind of don't need this because now you can make your query strings into template strings and just manipulate those directly. So let's just say I'm going to pull in an ID from my props and make that into query variables. It just is, when you can move that quickly, you no longer need to have static GraphQL files and standalone things. And that's what a lot of this tooling tries to get around. And really, you can just fix it at the source with Babel. Directives are really cool. So let's say you want to sort your example, sort your results. You just pass in a directive, and they all start with @ signs. So it's pretty easy to just add a sort directive over there. So hopefully you can see how coding your GraphQL in line with your JavaScript is a really interesting idea. And the last bit is fragments. Fragments are a toughie. So so fragments. Let's just say I have an actor component, and it's going to be a list, and it's going to okay. And I'm just going to have the name of the actor, right? Actor.name. Okay, so and here what I'm really trying to do is show you how you can use this similar syntax to set up fragments as well. Actor fragments equals create fragment on the type of actor, and I'm going to tag the actor in the same way. So actor, cons actor. This is a lot of, I guess there's a lot of typing. I'm sorry about that. But hopefully, once I set this up, it's more interesting to you in terms of how easy it is to type. Like it's not a lot of complicated syntax. Okay, so okay. Okay, so I think I may have made some sort of error over here. I don't exactly know where it is. Okay. Well, that is one example that is a little bit more complicated, and I don't want to waste your time in figuring it out. We do have a lot of tests for that, and you can look at the entire docs to see the example for fragments as well. This is a really interesting new way to do it, and I just want to tie it in. First of all, why call it Blade? Is because it's like inline GraphQL, and when I explained it to my coworkers, they were like, oh, it's inline GraphQL, and inline skating is rollerblading, so that's that's kind of win for it. But more generally, I want to tie this into the broader context of what's going on with the future of React, what I see is going on, which is the age of AOT, the ahead-of-time compilation. Typically, we have this dichotomy between client-side rendering, where all the work is done on the client side, or server-side rendering, where all the work is done on the server side. Now we have the Jamstack, where work is done in the middle, and then you push out the results of the compilation. And in similar fashion, this kind of work is being done inside of Babel as well, with new things like Babel macros, which Babel Blade uses. So these are really interesting opportunities that are all going on. React itself is exploring AOT compilations with Prepack, Gatsby, React Static. Angular is also doing that, Vue, Svelte. And I think that Babel macros is an interesting way to do this as well, to move more and more of your compilation in line and ahead of time. So that's my talk. I do, if you're interested in this, it's very beta, obviously, and if you're interested in using this at work, definitely contribute some tests, because everything is tested, and I'll make sure that the Babel plugin compiles for your use case. So thank you very much.
Yeah, there we go. Hey, I'm Christina Keelan. I'll get into that in a second. Today, I am here to talk to you guys about conquering Lighthouse, or alternately, what's the slowest part of your React app? It's probably images. A little about me real fast. I am a community manager, so I'm a little nervous. I haven't done a talk in a while, so thank you so much for letting me do this. And hi, Mars. I will see you tomorrow. Just want to say that real fast. Okay, so I wanted to see how many of you guys are familiar with Google Lighthouse? Okay, maybe like a quarter, a third or so. So that's good to know. And do you guys use it? Yeah? It's a really, really awesome tool. So that's kind of what I'm going to dig into right now. And why is this actually important to dig into things like this? because speed equals money. You want your site to be optimized for all of this. And things like engagement with your users, visitor retention, your SEO ranking, all of that. And speed, actually, as a fun fact, 100 milliseconds is considered instantaneous from what we perceive. If your users are having to do anything that's a second or less, they're going to be fine. But when things are taking 10 seconds or more, it's actually going to make for a very sort of like an incompatible user experience. And we want to try and fix that. So that's what Lighthouse is helping with. And we've got some stuff that helps with that too with Fly. So it's an open source tool, like I said, it's from Google, and it helps to see how humans perceive your app performance. And also like improve the quality of your web pages. They have audits for things like performance and accessibility. You can kind of cater it to what you guys are looking for. It's really, really convenient. You can do like a plugin in your dev tools, and it's pretty awesome. I kind of got a little addicted to checking out every page, and it's kind of an awesome waste of time if you're ever into that sort of thing. But React is actually very gifted in ways that Lighthouse respects. And that's because of React components. And that kind of helps with loading like your CSS, HTML, and JavaScript, as they're needed. So that helps a lot. And here's a good example of a modern React app. We've got Wayfair, and that's what I kind of dug into a little bit. Hope you guys don't mind. I was actually, yeah. Don't worry about it. It's okay, I swear. Unfortunately, we did have a 29. Sorry, guys. But no, this is going to be awesome. So things to notice. You've got your time to interactive, 22 seconds, like I said. Over 10 seconds is going to be a little bit less comfortable for your users. But they are so kind to give us opportunities. And this one in particular, deferring off-screen images is a really big opportunity. So we're going to dig into lazy loading with that. But images are very complex. But Wayfair does do a really good job with them. It's a very complicated app, very image heavy, carousels, all of these really sort of intense features that can slow things down. But like I said, with the components and everything, it does kind of add to sort of a nice flow with the carousel and all of your images loading through. But let's see where we can improve. So our standard way is, having like a low resolution image, SVG, and then using Intersection Observer API to kind of swap in for your quality when it's almost in view. Okay, we do have some cool options with Fly, so I'll dig into that a little bit too. And then in a React app in particular, just kind of go in since we're doing lightning talk. What's it called? Yeah, like I said, like the carousel preloads the images and the video data that's not visible. So tackling the lazy loading there means redoing that React component. Below the fold, then there's a lot more happening again. It makes the lazy loading difficult again. Let's see here. Let's kind of go. Okay, so we did do these things, and I'll dig into what we did in a second, but we were able to fix the opportunities that were presented, and it did give us an 84, which is fantastic. Our time to interactive is now at 5.8 milliseconds. We don't have to worry about the images, but things like third-party JavaScript also are big issues when we start digging into it, and that's not really fun for anybody. But the site could be a lot faster after we optimize the images with WebP, but unfortunately it's not. And it slowed down the time to interactive drastically. But again, this was caused by those interactions between the pre-rendered markup, third-party JavaScript, React, all of that. There you go. But digging in a little deeper, you can see like how intense it gets with like your HTML loading, all of this React state JSON. Let's see here. You see, it just keeps going. But then finally, your React is going to come in and load, and we're going to finally get to where we want to be, but it's going to be a lot slower by the time that actually gets to your users. They may be a little bit less inclined to stick around, Okay, but a lot of these React sites end up like this. But why does this happen? So we've got, our developer who's building this really great fast React app. Shoot, we got to start pre-rendering for SEO, performance, all this. Okay, let's use Redux and rewire it. Okay, I guess we need to start adding add stuff in there, and then it just starts to get sad again. So unfortunately, the third-party JavaScript kind of bums us out for our performance, but we do want to get to 90. And like I said, deferring the third-party JavaScript will help. Optimizing your image formats, like I said, with WebP, fixing your lazy loading images, I'd mentioned, and then loading what you need when you need it. Yay, there we go. But we can help. If you wanted to try it out, we've got a cool, really great features for, we call them our edge apps, but they do help to optimize this for you and make it really quick and easy. And we're open source too, so you guys can go, you can play with this. You can build your own edge apps that will maybe work for your projects too. But Fly will make it, easier with these options. And my slides are really sticky. Sorry about that. Yeah, it really does not want to. Oh, there we go. Okay. But if you want to dig into this a little bit more, we've got some quick and easy resources for you. If you check it out on fly.io/lighthouse, you'll get some cool articles that deep dive a lot more into the code for it. They give you some cool example apps that you can play with and everything. Or just go straight to Lighthouse and check it out too. It's really, really fun. It's really easy, and it really, really makes a big difference for your performance, which is kind of what we all need. We all do all the developer work, but we want to make sure that our users at the end are, comfortable and happy and are interacting with us too. So please keep in touch, shoot me an email, whatever. Let's, I like chatting on Twitter and all that stuff. Any feedback, pointers, all that good stuff. That's it. Lightning Talk's done. Thanks.
Hi, everyone. My name is Autumn. I am a software developer, do mostly JavaScript, front-end React Redux stuff at a company called Cloud City. Get into that in a minute. But today, we're going to be talking about unit testing your React components without wanting to tear your hair out later when you have to go maintain those tests, right? First, a little bit about me. A little bit about me. I'm first and foremost a musician. I play, I think I play 9 or something instruments total. I don't keep count. But I'm a functional programmer. I tend to use Clojure for that thing. I also write a lot of functional JavaScript and etc. I do React Redux and JavaScript stuff professionally. Have done consulting stuff on my own as well as with agencies and other companies and things like that. I have previously also worked in Ruby and PHP and Python and Java and a whole bunch of other wild nonsense that you probably don't want to hear about. You can find me on GitHub and Twitter at mixtetracord. Yeah, my slides are also being sticky. Cool. So let's get into the meat of this particular talk, where I need to start off with a preface, just putting a couple assumptions out into the world, and I hope y'all will come with me on them. The first one is that plain functions are easiest to test, right? You have an input, you have an output, and you can make sure that given the correct input, your function produces the correct output. You don't have to care about internal state of some object or some class, right? You can just literally pass this thing and make sure it gave you back the correct thing. The second assumption that I'm making in this test is that function composition, and I say functional composition in terms of what y'all probably were learning in high school math class. Assuming you have a well-tested function f that does the thing it's supposed to do, and a well-tested function g that does what it's supposed to do, you don't need to test the composition of f and g. In code, this looks like g open paren f open paren x close paren, right? You don't need to actually test that that glue that holds that together if you aren't writing code that isn't just JavaScript, right? So with these things in mind, these are kind of the guiding principles as far as this goes. With these two assumptions in mind, we're going to go through 3 strategies to make your React components way more easily testable. The first one is use functional components whenever you can, always, literally always. And this actually touches on a teeny tiny bit of the React kind of, I guess, I don't know, dogma maybe, which is always push state up. Push state up as much as you can. Push it into Redux if you have Redux and want to. Push it into application state in a higher application than your display components, for example. So on the left, you can see we have the traditional class-based component, which just has a this.state and has a bunch of stuff in it and whichever, right? On the right, we have a functional component, which is literally just a function, because that's how React works, and that's lovely, which takes a prop called expanded and does the same thing as the left side component does, just much more concisely and much more testably, right? Because this component only has to care about how to render the data that it is given. Doesn't have to care about storing that data itself, right? And so if you're using something like Enzyme, right, you can literally just render this component and make sure that there's an H1 and not a div. And then you can render it with an expanded prop and make sure there's an H1 and a div. And that's done. Like, that's this component tested. If you were doing that with a stateful like class component, you would need to care about whether it's been instantiated and at what point stuff renders and et cetera, and it just becomes kind of just a bigger pain for not much like actual win in the application that you're building. The second strategy I want to talk about is your unconnected components. So if you use something like Redux, or if you're using GraphQL or something, Apollo, whichever, it's a good idea to test your unconnected components. That way you don't have to care about setting up your Redux store. You don't have to care about making sure your data is all where you think your data should be. You just pass it directly in. And I wrote the slide before I listened to the talk that happened at 1:30. Apparently, you don't need to write map state to props and map dispatch to props functions. You can just pass a hash. So if you do that, this becomes way easier. Otherwise, you want to test those functions separately, such that you know that they work and you know that Redux works. So your component's getting the stuff that it needs. The third strategy that I want to talk about is what you're actually testing, and this is kind of more conceptual. Your test shouldn't care how your component does the work. Your test should care whether it gives you back the right answer. That's the only thing that your test code should have any opinion about. Because if you couple your test code to the implementation of a specific function, refactoring that particular function becomes way harder. If you have to care about, and this is another reason to prioritize stateless components as well, because if you have to care about what's inside of some hash in your object, like what's inside of your state, for example, you're necessarily coupling your tests to the internal state of that object. And if you start representing state in a different way, maybe you push that state up into Redux, then you have to change your tests again, right? You always want to just high level, like, given this input, make sure that you always return this correct output, and then we're good. And you can do whatever you want to in the middle. Just make sure that you give me back the right answer, and we're probably fine. Yeah, so I have a lot of opinions about the way testing works. I'm happy to argue with y'all if y'all have different opinions. Until then, thanks so much for having me, y'all. I appreciate it.